Good evening, students. So last class we were discussing about haloalkanes and haloarenes. So we had discussed the definition, what is haloalkanes, right? So these are halogen derivatives of alkanes. What we had discussed the general formula. Then what are haloarenes, right? So haloarenes are they are called as aryl halides. So they are halogen derivatives of arenes, right? Arenes means aromatic ring. So then we had discussed about the nature of CX bond. That is, what is the nature of the CX bond? So the CX bond, that is alkyl halide bond, it is a polar in nature. Why it is polar? Because of the presence of highly electronegative atom, right? So between carbon and halogen, the halogen is highly electronegative atom. So because of that, there will be polarity arised. Okay, so as a result, as halogens are highly electronegative, they will get partial negative charge and carbon will have partial positive charge. So this was the nature of CX bond, that is the alkyl halide bond, right? Then we had discussed about the classification. Okay, so how they are classified based on the number of, so first was the classification based on the number of halogen atom. Okay, so based on the number of halogen atom, if there are one halogen atom, then it is called as monohaloalkane. If there are two, then it is dihaloalkane. If it is three, it is called as trihaloalkanes. So based upon, so they are called as haloalkanes, right? So when you have a aliphatic ring and aliphatic chain, okay, and whenever you have an aromatic ring, then they are called as haloarenes. So here you can see the halogen atom is attached to a aromatic ring. So here only one halogen atom is attached, so it is called as monohaloarene. So here you can see 2, so it is dihaloarine, and here there are 3, so it is called as trihaloarine. Then next was based on the hybridization of carbon atom. So the compounds containing sp3CX bond, right? So what are alkyl halides? So we have seen what are alkyl halides and what is allylic halides, benzylic halides. So these are the examples of they contain CX bond with sp3 hybridization. Okay, so the carbon here is sp3 hybridization. So these are the examples for sp3 CX bond. Then compounds containing sp2 CX bond, vinylic halides and aryl halides. Okay, so this is the classification. Next, we had discussed about the properties. So we had discussed about the boiling points. Okay, then melting point. So today's class will start with the methods of preparations. So methods of preparations, they are from by your test tube textbook point of view. So there are many this what methods of preparation like from alcohols. Okay, so but I'll be discussing which are important from NEET point of view. Okay, so I'll be discussing the name reactions. So first we'll discuss the methods of preparation of haloalkanes. Okay, then later we'll discuss about haloarenes. So haloalkanes. So the first methods of preparation is from alcohols. Okay, from alcohols by using halogen acids. What do you mean by halogen acids? A different halogen acids like hydrogen chloride, right? Hydrochloric acid. Then what you say, hydrogen. This sulfuric acid. Okay, nitric acid. So these are halogen acids. They are called as halogen acid. Okay, so the first preparation is from alcohols. So so here by using your halogen acid. So here I've just given the definition. So reactions I'll be writing down. So meanwhile you can also note down this. Okay, so first is Groove's process. So very important, Groove's process. So what is Groove's process? So chloroalkanes. Okay, so chloroalkanes are obtained when HCl gas is passed in alcohol. Okay, in the presence of anhydrous ZnCl2. What do you mean by anhydrous ZnCl2? Anhydrous meaning there is no water content in zinc sulfur chloride. Okay, so there is no water content in zinc chloride. So it is called as anhydrous. Anhydrous meaning there is no water content in ZnCl2. So whenever, so how your chloroalkanes are obtained? When you pass HCl gas over, okay, in alcohol in the presence of anhydrous ZnCl2. This is known as Groove's process. So I'll write the reaction. So alcohols, okay, alcohols are treated with what? They are treated with halogen acid, that is HX. Okay, in the presence of anhydrous, okay, anhydrous ZnCl2, giving you what? RX, that is your alkanes plus water, okay, H2O. Okay, so this is the first method of preparation. So it understood. So here what is happening, you can see here, I'll just, so this is getting combined. Okay, so this is forming water and RX. So you're like this is the Groove's process. So alcohol, for example, now if I take an example, so any alcohol, I'll take ethyl alcohol. Ethyl alcohol is what? C2H5OH plus, okay, I'll take what? HCl. I'll take hydrogen chloride, okay, hydrochloric acid gas in the presence of anhydrous ZnCl2. What is the product obtained? Can anyone tell me? Yes, Priyanka, it is
Ethyl
correct.
chloride.
Yes, it is ethyl chloride. Okay, it is correct. Ethyl chloride. So C2H5Cl. Okay, so how it is getting combined? So your OH will get combined with H and C2H5Cl. Okay, so this is the plus H2O. So this is the first reaction groups process from alcohol. So first method of preparation of haloalkanes is from alcohols. Okay, from alcohols. So very important reaction groups process. So how do you obtain? So chloroalkanes. Why chloroalkanes? Because you are using hydrochloric acid. Okay, you are using hydrochloric acid. So you obtain chloroalkanes. Okay, so chloroalkanes are obtained when HCl gas is passed in alcohol in the presence of anhydrous ZnCl2. So this is Grove's process. Okay. Now, for example, if I use your HBr, okay, if I use your HBr, what will be the alkane obtained? If I use here, so if I use HBr, so what will be the product here?
Ethyl bromide.
Yes, ethyl bromide. Yes, correct. Okay, so it will be ethyl bromide. So likewise, based upon the halogen attached, your products will change. Bromoalkanes, chloroalkanes. Okay, then if you want to prepare, so here bromoalkanes are prepared. The condition is that bromoalkanes is not prepared in the presence of anhydrous ZnCl2. It is prepared in the presence of concentrated H2SO4. Okay, so the bromoalkanes are obtained when you react your alcohol with concentrated H2SO4, they form ethyl bromide. So this is the, so whenever you want to prepare bromoalkanes, so you have to react it with HBr, that is hydrogen bromide, and concentrated H2SO4. Now, the condition, if I want to prepare iodoalkanes, okay, so iodoalkanes are obtained when you heat your alcohols with NaI. Okay, you will be heating it with NaI. What is NaI? Sodium iodide. Okay, or it can be potassium iodide. So either you can use sodium iodide or potassium iodide in the presence of orthophosphoric acid, that is H3PO4. Okay, in the presence of plus H3PO4. Okay, this is a condition and you have to heat it. What you have to do? You have to heat it. Okay, you have to heat it. What you obtain? You will obtain your iodoalkanes. Okay, you obtain what? Iodoalkanes. So I'll write the general. So generally, if I write, it will be more clear. So you can use any alcohol. So whenever you want to prepare iodoalkane, so what is the condition? Alcohol should be treated with either sodium iodide or potassium iodide. Okay, plus orthophosphoric acid, that is 95% orthophosphoric acid. You have to heat it. What you obtained is what you get is iodoalkanes plus KH2PO4. Okay, so here I'm using sodium. So it will be NaH2PO4 plus H2O plus H2O. Okay, so this is the reaction for iodoalkanes, for preparation of iodoalkanes. So likewise, you can prepare your any alkanes. So chloroalkanes, iodoalkanes, and bromoalkanes. Okay, so this is group process. So the order of reactivity of halogen acid, okay, with on alcohol will be iodide is greater than HBr is greater than HCl. Okay, so and the reactivity of alcohols towards its tertiary is more stable. Tertiary alcohol is more stable than secondary and then primary, because in alkyl halides, you know that tertiary is more stable than secondary and primary because of the formation of carbocation. So that will be studying in further classes. Okay, so this is the order of reactivity of halogen acids with alcohol. So this is the first reaction methods of preparation, that is Grove's process. Okay, so next is Darzan's process. So I'll clear this. This is clear. The reaction is clear. Okay, so we'll go for the next one. So we'll go for the next one. Next one is Darzens process. Next is Darzens process. Okay, so there are I'm just going with the name reactions. Okay, important name reaction. So in Darzens process, the first is, so what is the definition? Okay, how it goes. So chloroalkanes are obtained by refluxing alcohols with thionyl chloride. Now what is thionyl chloride? SOCl2. Okay, SOCl2 is thionyl chloride. So SOCl2, so when you react your chloroalkanes, okay, when you react with your chloroalkanes with so chloroalkanes are obtained by refluxing your alcohols with thionyl chloride in the presence of pyridine. So your pyridine is acting as a base. So it is a strong base. Okay, so pyridine is a base. So you're using base. So this is known as Darzens process. So I'll just write the reaction now. So pyridine is a base. So we'll write the reaction. So here alcohols. So I'll write the general reaction ROH plus SOCl2. Okay, in the presence of pyridine. So I'll just write pyridine. Okay, so alcohols in the, with when it reacts with thionyl chloride in the presence of pyridine, what it will give you? RCl plus SO2 plus HCl. Okay, plus HCl. Okay, so like this is the this. Okay, so alcohol plus thionyl chloride. So in this reaction, the chloroalkanes which is obtained is what it is of major. It is giving a major product because here the other what you say, other products which are obtained, they are gaseous in nature. So they will liberate. Okay, they will be liberated or they will be removed easily. They can be removed easily because they will be evaporating. They will just liberate out. So SO2 gas and HCl will escape out. Okay, so your RCl, that is chloroalkane, which will be obtained, will be more. Okay, and it will be so this reaction is mostly used or it is preferred because the byproducts, the other byproducts which are used here or they are formed here, they are gases in gassing, they are gaseous in nature. So because of this condition, okay, so here, so by this process only, most of the time chloroalkanes are prepared. So what is the reaction? Chloroalkanes, so alcohols are treated with thionyl chloride in the presence of pyridine. Okay, you get chloroalkanes plus SO2 gas plus HCl gas. So SO2 gas and HCl gas will liberate out. Okay, so they'll just escape out. So this is Darzens process. So I'll give an example now. I'll take same ethyl alcohol. So C2H5OH plus SOCl2 in the presence of pyridine. What will be the product? What will be the product? C2H5OH plus SOCl2 plus give this in the presence of pyridine base C2H5Cl plus SO2 gas plus HCl. So this is the, so it is what? Ethyl chloride. Okay, so it is ethyl chloride. So this is the product which is obtained. Okay, so this is the second reaction, important reactions from haloalkanes. So next there are addition reactions. So you know what is addition reaction? Now suppose I've taken a alkene. Okay, suppose I've taken an alkene and I want to add halogen across this. Okay, what I want to do? I want to add halogen across this. So how do I add it? I will add it. So across the double bond, there are same number of atoms. So what I'll do? I will CH2 X and X, right? So this is the way I will add the halogen. Same with respect to, again, this reaction. CH2 plus H2O. So this H2O, how it will break H2O? H2O will be broken as H plus OH minus ions. Now across the double bond, how they will add? So CH2 double, sorry, not double bond, CH2, CH2. So across the double bond, there are same number of carbon atoms. So H can go and attack any of the carbon and OH can attack any of the carbon. Now, this is the case when you have, these are called as symmetrical alkenes. What they are called as? They are called as symmetrical alkenes. Why they are called as symmetrical alkene? Because across the double bond, okay, across the double bond, they have same number of carbon atoms. They have same number of carbon atoms. So they are called as what? They are called as symmetrical alkenes. Okay, so whenever you have a symmetrical alkenes, whenever you add, you do addition reaction, it will be same. It will be, you can add across the double bond any of the carbon. Now in this condition, so this was one condition. Now one more condition, CH3, CH double bond, CH2 plus X2, or I'll take it as plus water. Now how we will add it? How we will add? So these are called as, so across the double bond, are they having same number of carbon atoms across the double bond? So as you can see here, across the double bond, so here there are two carbon atoms, here there is only one carbon atom. So these are called as unsymmetrical alkenes. They are called as unsymmetrical alkenes. Why they are unsymmetrical? If you break across the bond, there are no same number of carbon atoms. Here it is one, here there are two carbon atoms. So they are called as unsymmetrical alkenes. Okay. So, so the next preparation, what we are going to study is from alkene. Okay, that is from alkene. So from alkene, so that is addition of hydrogen halide. Addition of hydrogen halide. That is HX. That is HX. Okay. So alkenes adds a molecule of hydrogen halide to form alkyl halides. This addition to unsymmetrical alkene takes place according to Markovnikov's rule. Now we'll see what is this Markovnikov's rule. So I'll give an example. So I'll take the same molecule, that is CH3, CH double bond, CH2. Okay, plus what they have done, alkene is added. Okay, alkene adds a molecule of hydrogen halide. So I will take hydrogen iodide. Okay, the reactivity is so hydrogen iodide, and what are the products obtained? Okay, so alkenes, they add a molecule of hydrogen halide to form what? Alkyl halides. So there is no symmetrical alkene. These are unsymmetrical alkenes. So whenever you have an unsymmetrical alkene, there is a rule called as Markovnikov's rule. So what does this Markovnikov's rule state? That whenever you have an unsymmetrical alkene, so across the double bond, okay, so whenever you have a hydrogen halide, okay, so hydrogen halide, in that the halide part will be added to the carbon having more number of hydrogen atoms, okay, and the carbon, the other part, that is hydrogen, will be added to the carbon having less number of atoms. Okay, so this is the this Markovnikov's rule. So whenever you have a this unsymmetrical alkene, it will follow Markovnikov's rule. Okay, so I'll just give an example, then you will be able to understand. So now this is what hydrogen halide. So what is happening? Hydrogen halide, when it breaks up into H plus and I minus. Okay, so the negative part of the halide, alkyl halide, will be added. Okay, where it will be added? It will be added to the carbon having more number of hydrogens. So where are the more number of hydrogen across the double bond? It is this carbon. So CH3. So other this will remain same. Okay, only change will be across the double bond. So it will be what? It will be CH. So CH3, and this will be CHI. Okay, so this is the rule. So whenever you have an unsymmetrical alkene, okay, unsymmetrical alkene, So the negative part of the alkyl halide, okay, negative part of the alkyl halide will be added to the carbon having less number of hydrogen atoms, and hydrogen will be added to the carbon having more number of hydrogen atoms. Okay, so this is one product. So this is a major product. Then next one more it will form. So another chance is what? CH3, CH2, CH2I. So this is a minor product. So here what is happening? Here the negative part is added to the carbon having more number of hydrogen atoms, and hydrogen is added to the carbon having less number of hydrogen atoms. So this is Markovnikov's rule. Okay, so this is Markovnikov's rule. So what does Markovnikov's rule state? So this is so whenever you have so by this also you can prepare your haloalkanes. So whenever you have unsymmetrical alkanes, you can follow Markovnikov's rule. Now another condition. So when if you add HBr, okay, if you add HBr, that is hydrogen halide in the presence of peroxide. Okay, what are peroxide? Hydrogen peroxide, sodium peroxide. Okay, so these are peroxide. So whichever peroxide, if you take HBr, that is alkyl halide. Okay, so hydrogen bromide. So if you take any halide, alkyl halide, sorry, hydrogen halide, okay, and if you take it in the presence of any organic peroxide, then addition will follow anti-Markovnikov rule. Anti-Markovnikov rule means what? Anti-Markovnikov rule is reverse of your Markovnikov rule. Here in Markovnikov rule, the negative part of the hydrogen halide is added to the carbon having less number of hydrogen atoms, okay, and in anti-Markovnikov rules it is reverse. It is reverse means what? Negative part of the hydrogen halide is added to the carbon having more number of hydrogen atoms. So this is anti-Markovnikov rule. So how you will understand it is following anti-Markovnikov rule or Markovnikov rule? So you can see that if it is written, okay, if it is written hydrogen halide in the presence of peroxide, for example, here I'll just give. So if it is like this, so if it is CH3, CH2, CH. Okay, so this plus HBr in the presence of, okay. Can you tell me, is it Markovnikov's rule or it will follow anti-Markovnikov rule? Yes, it will follow Markovnikov's rule or it will follow anti-Markovnikov's rule. Yes, it will follow anti-Markovnikov's rule. Okay, so whenever you have hydrogen peroxides, okay, in the presence of your hydrogen halide, then it will follow anti-Markovnikov rule. Okay, so simple, you have to remember. So remember one rule. If you remember Markovnikov rule, what you can do reverse. You can do what is that? Reverse for anti-Markovnikov rule. Okay, so this is Markovnikov rule. Now, one more reaction I'll just write here. Okay, you need to know this term. So if I take a, so if I take CH3, No, I'll not take, I'll take generally. So R CH double bond CH2 plus X2. Okay, in the presence of CCl4. So this is a organic solvent, CCl4 carbon tetrachloride. How it will react? So R CH CH2, so X2, so that will be added across the double bond. So whenever you have this, okay, halides, okay, which are adjacent to each other, okay, to both the carbon, then they are called as vicinal dihalides. They are called as what? Vicinal dihalides. So this test, okay, this test shows the presence of a double bond. So, or this is used for the test for unsaturation, to check the unsaturation. You know what do you mean by unsaturation? Unsaturation meaning either it will have a double or triple bond. So here the brown color of the bromine. So here X2 can be used as bromine. So here the brown color of the bromine, it will get discharged in the reaction. And this color change is used for the test for detection of unsaturation in the compound. Okay, so this is unsaturation test. So you have taken alkene, you are reacted with bromine and carbon tetrachloride. So if the color changes, if it decolorizes, that means there is presence of unsaturation. Okay, so this is a unsaturation test. So these are called as vicinal. Vicinal means across the adjacent to each other. Okay, adjacent to the each carbon, there is a presence of halide group. Halide groups are attached. Okay, so this is vicinal dihalides. So next example, next is Finkelstein reaction. So another very important reaction, Finkelstein reaction is very important, name reaction. So what is Finkelstein reaction? So whenever you react your alkyl chlorides or bromides. Okay, so whenever alkyl chlorides or bromides, so alkyl chlorides or bromides, when they react with sodium iodide. Okay, if they react with sodium iodide in the presence of dry acetone, they form alkyl iodides. So, whenever you want to prepare iodides, okay, so these reactions are mostly used for the preparation of alkyl iodides. Okay, whenever you want to prepare iodides, so this is the best reaction which can be used. So whenever alkyl iodides are prepared, you require, what is your starting reactant? You require alkyl chlorides or alkyl bromides. So they react with sodium iodide. Okay, they react with sodium iodide in the presence of what? They are reacted in the presence of dry ether, okay, to form the alkyl iodide. So this reaction is known as what? They are known as Finkelstein reaction. So here the reaction is given. So you can read the definition. Okay, what is the definition? So alkyl halides, that is alkyl chloride or bromide, reacts with metal iodide. So metal iodides are used here in the presence of polar aprotic solvent, which such as acetone, to give alkyl iodide and metal halide salt as precipitate. So this reaction is known as Finkelstein reaction. Then your Finkelstein reaction can be represented as follow. Now here is the reaction. So alkyl halide. So this is alkyl halide. This is sodium iodide. So in the presence of dry acetone, you get what? Alkyl iodide, sodium halide. Okay, so this is the reaction. So alkyl halide, when it reacts with sodium iodide in the presence of dry acetone, you get alkyl iodide plus uh, sodium halide. So this is called as halogen exchange reaction. So these are called as halogen exchange reaction. Okay, so these are called as what? Halogen exchange reaction. Why? Because you are exchanging your halogens. You can see here, if I take here chloride or bromide, okay, here what is there? Here iodide is there. So what is happening here? So your right. So your halogens are getting exchanged. Your halogens are getting exchanged, right? So because of that, so this is called as halogen exchange reaction. Understood till here? Yes. Am I going fast? Is it clear till here? If you want me to explain anything, you can just ask me to explain in between, okay? If you have not understood anything in the class also, you can just ask me here. So I can, so I'm just teaching you all the important name reactions. I'm not going to teach all the name reactions. So whichever is important, okay, because we need to do MCQs more. So I'm just going to stress on the main name reaction. So if you want me to do any specific name reaction, you can tell me. Okay, I'll do that also. If you have not understood, you can let me know. I'll just explain you once again. If you want me to explain anything, you can ask. Okay. Is it clear? Clear till here? Okay, fine. So this is another Finkelstein reaction. So this is what? This is a halogen exchange reaction. Yes. So we'll go for the next one. Next is Schwartz reaction. So this is also a halogen exchange reaction. Here they are generally used for the preparation of alkyl fluorides. So in the last, Finkelstein reaction is used for the preparation of iodides. Okay, it is used what? It is used for the preparation of iodides. Here it is used for alkyl fluorides. So the starting reactants, what you are going to take is alkyl fluorides or alkyl bromides. So either RCl or RBr. And what you'll obtain? You will obtain RF because you want to prepare your fluoride. So Schwartz reaction is generally used to get alkyl fluorides from alkyl fluorides or alkyl bromides. So your starting reactant can be alkyl bromide or alkyl chloride. Okay. So how it is used or how it is done, the reaction. So this is done by heating your alkyl fluoride or alkyl bromide in the presence of fluorides. Okay, it is used in the presence of fluorides with some heavy metals. So here the fluorides are fused with metals, heavy metals. For example, silver fluoride or mercurous fluoride, for example. Okay, for example, what is used? Silver fluoride or mercurous fluoride is used. Okay, so it is used for the what you say? It is fused. So you can heat your alkyl fluorides or alkyl bromides in the presence of fluoride, which is fused with heavy metals like silver fluoride, mercurous fluoride, etc. So you can see the example now. So what is the example? Example is CH3Br, so plus AgF. So this is what? AgF, silver fluoride. You get what? You get CH3F plus AgBr. So you can see here. So this is the side product which is obtained. And this will get CH3F. Understood? So instead of silver fluoride, other metallic fluorides like this is mercurous fluoride, cobalt fluoride. Okay. So these are the different fluorides which can be used. So one more name reaction, it is the Woods reaction. So what is Woods reaction? So Wood reactions are used to produce ethane from methyl chloride. So here you can see in the reactant there is only okay. So this will so what it you can see here. Okay, 2Rx. So you need to take 2 moles of alkyl halides. So in the reactants, they have taken 2 moles of alkyl halides. So 2 moles of alkyl halide is heated. Okay, it is heated with sodium metal. So this is sodium metal. So it is used or it is heated in the presence of sodium metal in the presence of dry ether to give you RR. Okay, what is RR? So it is a ethane. Okay, so RR, so this is alkane. So they produce what? Alkane. So alkyl halides are treated with sodium metal in the presence of dry ether to give you alkane plus sodium halide. Okay, so these are the, this is the Woods reaction, very important reaction, that is Woods reaction. So very important Woods reaction. So I'll give you example here now. So I will take CH3, CH3Br. Okay, CH3Br, 2 moles of CH3Br. So if you want, I'll just write it like this: CH3Br plus, plus 2Na plus BrCH3. Is it right? Right, I have just written it in the fancy form. Just see. So what will be a product? This will get eliminated, right? So you will be, this is your byproduct. Your product will be CH3 plus 2NaBr. Understood? So easy way to understand this. So this is Woods reaction. Okay, this is Woods reaction. Another example, CH3. Wait, I'll change the color. CH3, CH2Br plus 2Na plus BrCH2, CH3 in the presence of dry ether gives you what? It will form CH3, CH2, CH2, CH3 plus 2NaBr. Understood? So this is Woods reaction. Very important reaction. Very important name reaction. That is Woods reaction. Okay. I hope it is clear till here. So these were some of the what you can say, these are some of the name reactions. Okay. So these are some of the name reactions for haloalkanes. Next we'll go with name reactions for haloarenes. Okay. Haloarenes, oh, you know what are haloarenes now. So now next we'll see what are the methods of preparation for haloarenes. The first is Sandmeyer's reaction. So we'll okay, so first is Sandmeyer's reaction. So Sandmeyer's reaction is basically a substitution reaction. What do you mean by substitution reaction? Substitution reaction. Understood? So this is a substitution reaction. So one atom is being exchanged by other. You can see in the product. So one atom is replaced by another atom. Substitute. Okay, substitution or substitute means what? One atom is being replaced by another atom. So this is a substitution. So Sandmeyer's reaction is basically a substitution reaction which is widely used for the synthesis of aryl halides from aryl diazonium salts. So whenever you have a aryl diazonium salt, so this is aryl diazonium salt. Okay, how do you prepare aryl diazonium salt? So you have to take aniline, okay, aniline, and what is the condition? You have to treat it with sodium nitrate plus a halogen acid, okay, and the temperature maintained should be 0 degree to 5 degree. The temperature here, the temperature it should be maintained properly. So then this is called as diazonium salt. Then the diazonium salts are prepared. So this is the method of preparation of your diazonium salt. So the catalyst which is used in this reaction are copper salts like bromine, chloride, or iodide ions. Okay, so this type of substitution reactions is widely used in the production of aryl halides from aryl diazonium salt. Okay, so this is used in the production of aryl halides from aryl diazonium salts. So diazonium salts are a group of organic compound which share a common functional group. So the functional group is RN2, okay, plus X. So you can see here, okay, you can see here. So R can be your alkyl or a aryl residue. Here you can see N2X. Okay, so this is the so here so this is the diazonium salt. So how diazonium salt is prepared? You have to take aniline. The condition is 0 to 5 degrees Celsius. You have to make a solution of sodium nitrite plus concentrated hydrochloric acid. Okay, and make a solution, and slowly you have to add it to the aniline, which is kept in a ice bath. You have to maintain the temperature for 0 to 5 degrees Celsius, and you prepare is diazonium salt. So this diazonium salt is further treated with Cu2X2. Okay, Cu2X2. So cuprous halides. So you have to make use of cuprous halides. Okay, you have to make use of cuprous halides. So you can make use of cuprous halides. And what is obtained is a aryl halide. So aryl halide is obtained plus N2. So this is the simplest Sandmeyer's reaction. So you have to prepare. So you always for Sandmeyer's reaction, the diazonium salt which is prepared, it will be prepared by using freshly prepared diazonium halide. That is only. So whenever a freshly prepared diazonium halide is mixed with cuprous chloride or bromide to form chloro or bromoarenes. Okay, so this reaction is called as Sandmeyer's reaction. So you have to prepare the diazonium salt it should be freshly prepared. So it should be treated with your cuprous or chloro or bromo, this cuprous chloride or cuprous bromide. Okay, so this is your Sandmeyer's reaction. So this is Sandmeyer's reaction. So Sandmeyer's reaction is very important name reaction. So you can see. So this is benzene diazonium salt. So what I'm telling here in words. So I'll just write. So this is aniline. So this is 0 degree to 5 degrees Celsius. This is benzene diazonium salts. Okay, benzene diazonium salts. Okay, so this is cuprous bromide or cuprous iodide. So X can be a cuprous fluoride or bromide. So cuprous. Okay, cuprous bromide or cuprous iodide is used here. Okay, plus so this is your haloarine. Okay, so this obtained is haloarine. Okay, so this is your Sandmeyer's reaction. I hope this is clear. Yes. So one more reaction and then we will stop. Okay. So the next reaction is Wurtz-Fittig reaction. So Wurtz-Fittig reaction is also very important reaction. Okay, Wurtz-Fittig reaction. So Fittig reaction. So in Fittig reaction, you have to take both aryl groups. How we have taken this, that is Rx plus 2Rx plus 2Na. Okay, in the presence of dry ether gives you 2 RR plus 2 NaX. So this is your Wurtz. This is your Wurtz. Now what is Fittig? Fittig is this. 2 plus 2Na in the presence of dry ether giving you plus 2NaX. So this is what? This is Fittig. Right, this is Fittig. Now what is Wood-Fittig reaction? So see here, Fittig reaction was developed as a coupling reaction of two aryl halides. So you have to take two aryl halides. So when you take two aryl halides, you heat it with sodium in the presence of dry ether, you get a biphenyl or diphenyl. Okay, it is called as diphenyl or biphenyl plus 2NaX. So this is a Fittig reaction. Now what is Wood and Fittig? In Wood and Fittig, what you have to do? You have to do the coupling between an alkyl group. So this is an alkyl group and this is a aryl group. Okay, so now you have got an idea that Woods is of alkyl. You have to do a coupling of alkyl group in Fittig. Only Fittig, it is for aryl group. The coupling is made between two aryl halides, and Wood-Fittig, you have to take one alkyl and one aryl group. Okay, so here you can see the reaction now. So this is a aryl halides are treated with aryl halides and alkyl halide. Okay, is treated with sodium in the presence of dry ether. Okay, so this is Wood-Fittig reaction. So this is a Wood-Fittig reaction plus 2NaX. So Wood-Fittig reaction, it involves the coupling between an alkyl and aryl halides instead of one alkyl or aryl halide. Okay, so this is very important reaction. So this is a Wood-Fittig reaction. So next is nucleophilic substitution reaction. So for today, this much is enough, I feel. Okay, nucleophilic substitution reaction we can do in the next class. If you have any doubts, you can ask me. So after this, I'll be just stopping the class because name reactions are enough for today. Okay, again, you will get confused. So this much is enough for today. If you have any doubts till here, whatever I have taught, okay, I'm just covering the important name reactions. Okay. So any doubts? Just a second. Okay, fine then. So shall I stop here? Yes. If there are no doubts, okay then. So nucleophilic substitution reaction will start in the next class. Okay. So whatever has been taught today, just go through it. Thank you. I'll stop the class here.